Hi everyone, this is Adam again. So today I'm going to be going over Geometry 1. Okay, so just kind of some of the basics that hopefully you would have remembered from your junior cert, but just in case. So a perpendicular line, lines are said to be perpendicular if they are 90 degrees along here. Okay, and then this kind of corner sort of a thing, that also means 90 degrees. Okay, so that's if lines are perpendicular. If lines are parallel, you'll see two lines like this. It basically means they're in the same direction and they'll never meet. Okay, so that's all parallel lines are. Okay, so now there's different angles. So if you have, say this is B, this is C, this is A, and you want to write this angle, you would say that this angle is equal to angle ABC, or you'd say it's angle CBA. Okay? So it doesn't actually matter which way you write it, as long as the B is in the center. Okay? So the B has to be in the center. Why? Because B is the point that you're kind of measuring it from. Okay? So if you go from C to B to A, that's this one. If you go from A to B to C, it'll map out the same angle. So it actually doesn't make a difference. Okay? So then you have an acute angle. This is an angle that's just less than 90. So the angle here, call it A. If A is just less than 90 degrees, you call it an acute angle. Right angle is obviously just equal to this. And obtuse is just equal to when the angle is greater than 90, sorry. So when A is specifically greater than 90. Okay, so here, if I kind of get rid of this one and just call it A, just to make things a bit more, A would equal 90 degrees. Okay, so that's kind of that. You have a straight angle, which is just 180. You have a reflex angle, which is greater than 180. And then that's basically it. Okay? Okay. So that's kind of that. All right? So now the next thing. So again, there might be some things that I'm skipping in your book. And that's basically just because I don't think they're necessary. So I'm only going to go over the things that I think are necessary. Okay? So basically, okay, and this is actually a thing that you need to know in a junior cert. I don't think you need to know it in leaving, but I'm just going to write it anyways. So basically, I'll start off with what an axiom is. Basically, an axiom is just a rule that we accept without proof. So I'll just give a little bit of history on maths. Like obviously, maths has to kind of just a few hundred years ago. Well, not really a few hundred, but like recently in recent kind of maths, one thing that people wanted to say was, well, can we prove absolutely everything? And the answer is no, you can't. So there's always some things like axioms that's a rule that you're just going to have to take that, yeah, this is just true. Okay? I think there's 4 or 5 axioms of maths that you've taken initially, and every single thing can be proved from that. Okay? So it's one of those things of, obviously, it's like you might say, okay, well, 1 plus 1 is 2. You take that as being given. And then from that, you can say, oh, well, that means that 2 plus 1 has to be 3. Because if you add 1, you get the next number. So what's the next number after 2? It's 3. And therefore, 2 plus 1 is 3. So you can prove things from these axioms. But these axioms, sometimes you actually can't prove them themselves. Okay? So an axiom is, I think one of the axioms of maths is basically that if you have like a page like this, and you draw 2 dots, one of the axioms is that you can always draw a line that'll go through those 2 dots. So that's one of the things that no one can actually prove. But we just take it that it's given. So it's obvious that it's given, that, and of course you can do it, but we just haven't proved it. Okay, so that's all an axiom is. So you just need to know an axiom is a rule that we accept without proof. A theorem is basically a rule that can / has been proved using other theorems or axioms. Okay, so basically an axiom is a rule that we haven't proved. A theorem is a rule we can prove. That's kind of all. And a corollary is basically a rule that follows on from a theorem. So it's kind of like, once you prove a theorem, a corollary is basically anything that kind of follows obviously after that, you know. So maybe you might say, a theorem could be something like, oh, all even numbers are divisible by 2. And then a corollary is basically, oh, that means that 8 is divisible by 2. That's kind of what a corollary is. It's like, oh, from the theorem, you can say, oh, this is obviously true. And that's kind of all, okay? A converse is actually quite important. Converse is basically, it's like the reverse of a theorem. So not opposite, be careful, I'm saying reverse, so not opposite. So it's like saying a square is a rectangle. That's, say, a theorem. And then the converse of that theorem would be that a rectangle is a square. So you just basically swap the two things, okay? And that's kind of it, all right? Okay, so now, a couple of the proofs that you actually will need to know is that all angles in a triangle add up to 180, okay? So if I do this, say this is A, this is B. Okay, sorry, I might actually just change to numbers because I'm assuming that's what everyone will be working with. 3. And I asked, okay, prove that all the angles add up to 180. Basically what you can do is, okay, this is kind of annoying. Yeah, okay, no, sorry, I'm actually going to, 1 second. I'm going to go over the different types of angles first, and then I'm going to come back and do this, okay? So, first of all, the angles, this angle is the same as this angle, and this angle is the same as this angle. If this is the case, they are called vertically opposite. Okay? So vertically opposite, basically they're just opposite of each other. So if I kind of rotated this around, this thing would look the exact same as this, because these two things are straight lines. Okay? Then the next thing is alternate angles. Okay? So alternate angles is basically when you have some sort of a Z shape, like between this one and this one. So angle 1 equals angle 2 in this case. Okay, because they are alternate. And you might be asking, and also this only works, if these are parallel. So you have two parallel lines, okay? The way you would see this is, when I say Z, I mean this. See the way that's a Z? And the same thing, this angle, say that's 3, is this angle. Because this is also a kind of Z. A little bit of a weirder Z, but it is kind of that same zigzag shape. Okay? So this would be alternate angles, if you can get a kind of a weird sort of a Z shape. All right? I think the very last one is corresponding. There's corresponding, and then there's going to be interior as well, but corresponding would look something like this. If you have two lines, again, they're parallel, and you draw a line down here, this angle is the same as this one. Because again, this is just parallel, and therefore, because they're parallel, it makes the same angle. Okay? The same with this one. This one will be the same as this one. And the very last one then, so also this is kind of like an F shape, which sometimes kind of helps to think about it, that you're getting like an F out of it, okay? And then finally, interior angles, if you've two lines, again, parallel, and you have this angle, and this angle, will be 180. The reason is because this angle A is the same thing as this angle here because of the Z. Okay, so again, they are alternate. And again, this is just a dead straight line, which means that A and B have to be 180. Okay? All right, so now I think I'll go back and do the proof, because I need to use some of those angles to prove it. So basically, you want to show that all the angles in a random triangle equal 180. The way you do it, so the way you do this is basically you always say that, what is it I want to prove? I want to show that angle 1 plus angle 2 plus angle 3 equals 180. Okay, so that's basically what I want to show. So that's what I want to end up with. So what I can do is I can say, well, if I draw a straight line across here and call this angle 3, angle 4, and then this is angle 5, I can say, well, this is just a straight line. Okay, so if this is a straight line, then I can say, well, I know that angle 4, angle 5, and angle 1 are equal to 180. Okay, because it's just a straight angle, and you always have to give a reason. And then I can say, well, here, this is parallel to this, which means I can use my different sort of angles up here. And I can say, well, here's a Z, which means 2 and 4 are alternate. And so they are alternate. And therefore I can say that angle 2 equals angle 4. The same thing with 3 and 5. I can say, well, this is a Z down here, and therefore angle 3 equals angle 5. So again, it's just alternate, okay? So if I replace 2 and 3 up here, I get angle 2 plus angle 3 plus angle 1 is equal to 180. Okay, so this is what I wanted to show. And this is what I have shown. And therefore, it is proved. Okay? All right. So the next thing I want to do, I want to do a couple of problems here before I move on any further. So if I want to solve for something like this, so this is 5x, this is 7x minus 4, this is 8x plus 4, and this is 11x minus 12. Okay? How will I solve what x is? Well, simply, up here we said that a straight line is 180. Of course, a full rotation is 360. And therefore, if I add all the angles up, I need to get 360. So if I add these up, so 7x plus 5x plus 8x plus 11x, that's going to be 31x. Minus 4 plus 4 minus 12 is just minus 12. Okay? So I get that 31x is going to be equal to 372. All right? So x is going to be 372 divided by 31, which is 22, I think. Sorry, 12. Yeah. So x is just equal to 12. Okay? I'll just do another one. Something like this. So it says that this angle is the same as this angle, and it says that this angle is 8x minus 8, and this angle is 5x plus 10. So here, to figure out what x is, I can say, well, 8x minus 8 has to be equal to 5x plus 10. Minus 5x off both sides and add 8, I'm going to get 3x equals 18, so x equals 6. Okay? So that is basically that. Okay. So I think I'll do a couple questions over here. And then I might... What time did I start that? Okay, not too bad. I'm probably only 20 minutes in, so not horrendous. Okay, so what I want to do for this one is I'm going to solve... Okay, this one looks quite hard. So I have 3 lines, and they're all parallel. I have a triangle, like this. This is angle A, this is angle B, this is angle C, this is 40, this is D, and this is 110. And basically it's just saying solve for A, B, and C. So very first thing that I'm looking at, I have an F here between these two. So I have that B is instantly going to be 40 degrees. Okay. I have another F over here. So C is just going to be 110. Okay. A is alternate to B, and therefore A equals B, and therefore A is also equal to 40 degrees. And then for D, well, I can say that this here, okay, I'm kind of running out of colors, but here, I can say that this is a straight line, which means D plus 110 has to equal 180, and therefore D has to be 70 degrees. Okay? All right, so that's that. So now I think I might leave those questions because I don't think they're as bad. All right. I might just do one more. Yeah, I might just do one more. So the next one that kind of looks a bit horrible is this one. It's two lines, both parallel. You have a line coming down here, which stops here. This is 25 degrees. You have a straight line coming here. This is B. This is 50. This is A. And then this is C. Okay, so first of all, we have that these two are vertically opposite. So I can instantly say that C is equal to 50 degrees. Okay? And I can also say that B is 50 degrees because here I have an F. Okay, so B is also equal to 50 degrees. Now, for A, you have to do an awful lot more work. So there's two different ways you can do it. I'm not sure which is easier, but I'm going to do both ways. So first of all, this angle here. So try and think, what is this angle here equal to? Again, pause the video if you want to think about it. It's 25. Because these two are alternate. So I can find my Z. So this way I can say, well, hold on, I have a straight line here. And therefore I can say that 25 plus A plus 50 is equal to 180. And therefore A is going to be equal to 105 degrees. So that's one way you can figure out A. The other way is you could say, well, here I have that these two are vertically opposite, and therefore this is 50. You could also say that this is alternate to this angle. And then you can say, oh, well, the three angles in a triangle add up to 180, and you get the exact same equation as this. So there's typically multiple ways of doing it. Okay, it's just whatever you find easiest and whichever you see first. Okay. Okay, I'll do angles in a triangle, and I might leave it at congruent triangles before I move on to anything else. Yeah, so I might finish triangles, and I think I'll stop there. So you've three types of triangles. You have equilateral, which is basically everything is the same. So all the lengths are the same, and all the angles are the same. Okay? So sorry, this symbol here means that it's the same length as this and this. Okay? In an isosceles, basically you just have that. So this is equilateral. This is isosceles. So isosceles is basically you have that two angles are the same and then two sides are the same. So this side is the same as this side, and the side that's opposite to the angles are the same. Okay, so see the way that this side here is opposite this angle, and this side is opposite this angle. So it's those ones that are the same. Okay. And then finally you have scalene. Scalene basically never come up, or well, sometimes they do, but you know, it's not really important that you know it's a scalene because it just means that nothing's the same. Okay, so scalene, you would have that nothing's the same. Okay. All right. Another theorem that comes in handy. This is angle 1, this is angle 2, this is angle 3. Angle 1 is equal to angle 2 plus angle 3. Okay? So that's just an exterior angle. Okay? This is kind of easy to prove. If you say that this is angle 4, you'd say, well, angle 1 plus angle 4 equal 180. But you can also say that angle 2 plus angle 3 plus angle 4 equals 180. Therefore, these two things are equal. Get rid of the 4s. You're just left with 1 equals 2 and 3. Okay? All right, I'll do one of these questions. Okay, I'll do two of them. So, one, ooh, that's actually kind of hard. Okay, no, never mind, sorry. So you have this, okay? So you have one triangle here, and you have another triangle here. So now this second one is equilateral, and this angle here is 33. This is angle A, this is angle C, this is angle 51, and this is B. And they're basically asking you to figure out what A, B, and C are. So, first of all, the very easiest one is going to be this one here. Because this is equilateral, which means this is 60 degrees. Okay? So I have that angle C plus 60 has to equal 180. So C has to equal 120. Okay? So that's the easiest one. Now, the next easiest one is, and again, when I first looked at this question, I didn't actually know how to solve it. It was quite hard. But one thing that you have to remember is, what piece of information haven't I used? I haven't used the fact that this is 33 degrees. So realistically, that's probably what I need to do. So that's one of the things in geometry. It's if you're sitting there and you're like, I have no idea how I'm going to solve this, all you have to do is just sit there and say, okay, let me just relax for a second. There's a piece of information that they haven't given me. Sorry, that they have given me that I haven't used. And therefore, it's probably something to do with that. So one of the things is just simply, here's a triangle. I have this angle, I have this angle, so I can figure out what B is. I can say that B plus 33 plus 51 has to equal 180. So B plus 84 equals 180. So B is going to be 96. Okay? And then finally, for angle A, I honestly don't know how to do angle A apart from the way that I'm going to do it. No, never mind. Sorry, I do know. So, sorry, here. I can figure out this angle. Because, again, all the angles in a triangle have to add up to 180. So this is going to be 87. So 87 plus 60 plus 33 is equal to 180. Okay? So now I can just go a straight line and say, well, A plus 87 has to be 180. So A has to be 93 degrees. Okay? So that's how you do that one. I'll just do another one. So another one is here. You have this, you have a triangle like this, and then you have a point here. And basically this is the same length as this, and it's the same length as this. And this is angle B, and this is angle A. Okay? So basically what they're asking you to do is they're asking you to say, okay, well, prove that angle B is equal to 2 times angle A. Okay? So, first of all, this is isosceles, which means that this angle here is also A. Okay? And now I can simply say that the interior angles of a triangle have to equal the exterior angle. So I can say that, well, that means that A plus A has to equal B, and therefore 2A equals B. And that's what I was asked to show. So that's it. So no more working out. Okay? So that's that. The next thing is going over congruent and similar triangles. Okay. So I'll just be very clear. Okay. So congruent triangles mean that everything is the same. Okay, that's all you need to know. Every single thing is the same. So all the lengths are the same, all the angles are the same. That's congruent. Similar triangles is all the angles are the same, but they could be different sizes. So they're similar because they look the same, but one could be bigger and one could be smaller. Okay? So that's the difference between congruent and similar triangles. So now we're doing congruent. So everything is the exact same. Okay? So congruent would look something like this. Say this is 60, this is 80, this has to be 40, this is 6.5, this is 7, this is 4. The congruent triangle of this would basically be if I just flipped it and said this was 7, this was 80, this was 4, and this was 6.5. 6.5 and 60 and 40. And now just be careful. If you look here, what's the opposite side to the 40? It's the 4. So in this triangle, the opposite side to the 40 is also the 4. That's the best way to do it. Guys, just if you're sitting there like, oh, I don't know if they're congruent or not, this is basically how you would tell. You would look and you'd say, okay, well, the 6.5 is opposite what angle? The 60 here. The 6.5 is opposite what angle over here? The 60. And then the same thing with the 80 and the 7. Okay? So, how do we know if triangles are congruent? So one thing you would prove is that it's SSS. So if you prove all three sides are the same, then you prove they're congruent. You can also do side angle side. So if you prove that two sides are the same and one angle are the same, then you also have that they're congruent. You have angle side angle. So if you prove two angles and one side are the same, then that means that they're also congruent. And then you also have RHS. So this is basically where you have the right angle, you have the hypotenuse, and then you show that one other side is also the same length. That's how you prove that they're congruent. Okay? All right, I don't think it's that important to do. Okay, I'll just do one proof. Okay, so one would be something like this. You have this, this, this. This is D, G, F, and E. So I'm just labeling all the points. This is a right angle. And this angle is the same as this angle. And it says prove that the triangle EDG is congruent to triangle EGF. Okay, so just prove that this triangle on the left is congruent to the triangle on the right. So first of all, this side is common to both. So what you would say is you'd say that, oh, well, that side is E, G equals EG. So I've shown that at least one side is the same length. So I have the S part of it. This is clearly also a right angle. Okay. So I have that the angles are the same. So the angle EGF is equal to angle EGF is equal to angle to EG. Sorry. EGD. Okay? Sorry, I don't know why I did that. I just rubbed that out. There we go. So you have that these two angles are the same. So I also have that angle, the angle part. And the other one, I have that, well, EDG is equal to angle EFG. So this angle is equal to this angle, which I'm just told from the question. And then you just say, therefore congruent. This thing just means therefore. Okay, so that's all I've said. So this, in this case, it would be the angle, side angle that I proved. Okay. Okay. All right. So hopefully that's all okay. The next one is they might ask you, they might say, okay, well, how do you tell if something is a triangle or not? Now that might sound like a stupid question, but if I asked you, is this a triangle? So now sit and think about your answer. If I asked you, is this a triangle, would you say yes or would you say no? If you'd say yes, why would you say yes? And if you're going to say no, then why would you say no? The answer is no. Basically, these two lengths added together have to be bigger than 6. And they're not. Okay? So in this case, it would just be a straight line. This angle here would be 180. This angle would be 0 and this angle would be 0. So there actually isn't a triangle. Because a triangle, hopefully that makes sense. Because if I told you this is point A, this is point B, this is point C. If I said walk from A to B, you might walk a length of 10. If I told you to walk to C first and then walk to B, you'd have to walk a longer length. So if this is 5, this might have to be 6 or 7. Or 8 or 9 or 10 or 11 or whatever. You know, but what it has to be bigger than this side. So if you have any triangle, like this, let's say A is your longest side and B and C are your shorter sides, then B plus C have to be greater than A. Okay, this is officially called the triangle inequality, but yeah, that's kind of it. All right, so now it'll just say a question, just like this. This is 7.2, this is 6.1, this is n. It says, what's the smallest? So first of all, what's the smallest that n can be? So the smallest that n can be, well, if n is very small, then this is the biggest one. So it's the longest side. So that means that n plus 6.1 has to be greater than 7.2. And therefore n has to be greater than 1.1. Okay? So the minimum value of n, it just has to be bigger than 1.1. Okay? For the maximum value of n, well, if n is now a max, then all of a sudden this is the biggest side. So now you have that 6.1 plus 7.2 has to be greater than n. So 13.3 is greater than n. So if you want this triangle to work, n has to be between 1.1 and 13.3. That's the only possible way you can make a triangle. Okay, which is quite interesting. You know, that you can't just throw any sides together. It has to be pretty specific. Okay. Okay, I might just finish this chapter. I only have 4 more pages. You know what? No, I think I'll leave it. I think that's kind of a nice place to stop. And then I can go over the parallelograms and stuff like that in the next video. Okay, so I think I'll leave it there. So thanks so much for tuning in. And I suppose I'll talk to you next video. Bye.